Okay. I do want to start, though, with something that people have asked me about, and that really highlights the scholar activist side of the story, and that is that while the overall message I'm going to highlight is really that the solutions that we found that really work to bring energy resources to really disenfranchised populations is one that you need some research, you need a vision to put it into practice, and that these are really team efforts where science enables activism, whether it's activism in Sacramento to meet clean energy goals at the state level, or whether it's activism to bring poverty to kind of classic disenfranchised poor in rural huts or in peri-urban communities. That's all fine and true, but I do think that this is a moment where, while the Vatican may have centuries of patience, certainly us Americans do not. And the existential crisis that we are facing with our recent election is one that has really highlighted something I'll say first, and that is this elephant in the room of the attack on science we're seeing. So I'll give a brief summary of that in the beginning, and then I'll very quickly do intra-household issues, some solutions that we've seen really work to bring energy services to the poor, frequently disenfranchised women. It'll touch back on this stove topic, and then a new parameter in all of these issues, which is mini-grids, an area where there's a great deal of discussion, great fascination, but few quantitative detailed studies. And then how does the large-scale traditional grid, how can it be transformed to really make energy resources available for the poor? So I'll do them fairly quickly. And again, I'm going to start off with this letter that I wrote when I resigned my job as science envoy, a position I did not want to resign from. But I did it for the reasons many of us have talked about, because we are facing a crisis in the United States right now where science is not valued in the ways that we're working. And so I wrote this letter. I did coordinate with a few friends. J.K. Rowling was kind enough to retweet it. That definitely had the desired effect. It then, you know, this is something that got over 125,000 likes in one day, to Jeff's point before. And it wasn't just my clever use of quotes from Ike Eisenhower and others, I fear. It was the fact that there was this acrostic in it, smaller than I thought it would be, that highlighted impeach. We now have a California billionaire running a $10 million impeach campaign. And I do feel this is the moment when this sort of thing really needs to happen. And it speaks to exactly what Jeff highlighted before. And then we got versions of my acrostic that took new forms. Of course, since I technically worked for Secretary Tillerson, although I was, of course, appointed by Secretary Kerry, it is a worthwhile version, because I do think that this is the kind of moment when, if we don't find ways creatively or otherwise to stand up and protest, we will do what I've seen many people do after the fact, and that is claim falsely that they were at Woodstock, or claim they were falsely leaders in various movements. And I know many, many friends who I've documented, they were not doing the thing which they said they were doing after the fact to make a difference. And I fear this is one of those moments when we have to be bolder than we would otherwise be, despite some interesting risks. And since Breitbart has targeted me since then, this definitely has caused a few of those. The warning for my 3 quick comments is going to be that the energy research community has a track record of abysmal failure when it comes to thinking through and understanding theory. And I'm going to come back to this again and again very briefly. We consistently get it wrong. And that's, if nothing else, I don't think that's because they're less smart individuals in this field. It's that if you don't engage on the practice side, the kind of use-inspired basic research that I highlighted in my written comments, we just don't get it right. And that's been a tragedy. And so I go back to my first project, when I made the transition from theoretical physics into energy research, where we worked on clean cooking technologies, in this case in Nicaragua and in Guatemala, and we engaged with the priests directly. This was the time of revolution theology, and it really made a difference in terms of understanding the connections and how to get these clean technologies into place. When we look at the very important, and Jeff made a wonderful pitch for the Sustainable Development Goals, one of the features that it's easy to say but incredibly hard to do in practice is that the boxes that these literally are need to be expanded. And so while renewable energy goal 7 alone is the one that I'll talk about, comments I'll make just in the next 14 minutes, literally connect to all of these. And I don't mean in some tangential way, in terms of gender equality, in terms of food security, in terms of poverty alleviation, in terms of conflict issues. This very short talk I'll do here isn't just peripherally related to these, it is directly related to all of those themes. So if we can't work with funding agencies, with the kind of voice that the Vatican, the Pontifical Academy, foundations have, we won't get it right, because a focus just on clean energy is simply not enough, even if you are focused in that area. Certainly my team at Berkeley is. And so I won't do at length, because we've heard a lot about cook stoves. I am somewhat distressed, because we do know that the burden of cooking is hugely gender disproportionate. It's actually women and children that do most of the work, and that our ability to get it right in terms of stoves is really remarkable. So this is in Nairobi's largest slum, Kibera, a country that, despite huge economic progress, is suddenly mired in yet another political crisis that could derail the country which is showing the fastest growth around the world today. So in terms of, instead of doing the full details of the cooking story, all of which I hope we all know, not just academically, but from being in some of the places where the cooking smoke is so remarkably high, this is, of course, a whole life cycle of making fuels, of stoves. The picture on the far right you can barely see is actually our most successful effort to get stoves into people's hands, and that's bringing a popular rapper from Kenya to talk about not only improved stoves, but opportunities to use stoves that can also charge cell phones. A whole variety of technological innovations that really boost the attention to these areas. And so we heard a lot about the issues of the dose response curves before. Well, the first part of that process, this is a Pokot woman in a community we started a stove project on in early 2000s, looking at and examining the various different stove technology options. These some burn wood, some burn charcoal, and in fact, we had great, wonderful academic papers and detailed work to highlight the dramatic reductions in pollution that you get by going to that stove on the left, the three-stone fire, all the way to the most improved charcoal burning stoves. I just put little icons on them here just to kind of highlight the different stoves. And that's a really nice start. We did a full version of the analysis of the pollution reduction by going to those simple three-stone fires down to the most improved stoves. And the big worry we had, and it was highlighted earlier today, was that if you start out at 7 or 8 or 9,000 micrograms per cubic meter, there's a legitimate argument. Why bother if a stove that works well will bring the pollution down by 60, 70%, when we know that the levels that we expect to see in developed countries are on the order of 10, 12, 20 microns. And what we found was that despite that claim that even a good stove that reduced the percentage a lot wouldn't actually bring the levels down to kind of US style, you can see here we found more than a factor of 2 reduction in acute respiratory illness. Not just pollution levels, but actually observed by doctors in the region, reduction in the observed amount of respiratory illness among those individuals. And we've had some technical back and forth about the quality of the studies, but this is an example that if one really does follow it through, these can really work. And this is something we published long ago, 2001 in the Lancet. Now I'm going to transition out of stoves to highlight that one version of this ladder, which is not just improving stoves to get more efficient stoves, less polluting, is the far end of the so-called energy ladder that Kirk Smith coined in the 1990s, and that is at the top of this are going to electricity. And that's really my transition point to a new parameter on the horizon. When solar power, when mini-grids using microhydro and wind were expensive, there was no chance to think about electricity for cooking. That world has changed. In fact, if you look at some of the many other uses of simple fuels, tin lanterns available in almost every poor developing country that can cost 50 cents to buy can cost you $50 during the year to buy the fuel. And so there is a huge opportunity. Fuel-based, these kind of fuel-based lighting in Africa is estimated to be a $20 billion industry, and those are funds that's not available to make rich entrepreneurs more wealthy, but that is a measure of how much economic activity from the very poor goes into these technologies. So I was in the room, literally in the Hamilton sense of the word, when I heard aid agencies at the World Bank, at USAID, at CEDA, at Italian Aid, and others all say that the improved lighting systems that we were talking about were no more than glorified flashlights. Devices like this that had a solar panel, an LED light, a little lithium-ion battery were not worth the effort because these were just, glorified versions of little flashlights. Well, in fact, more people last year and the year before and the year before who did not have electricity access before received their first doses of energy through these small pay-as-you-go off-grid products than through grid extension worldwide. And so something that all of these so-called experts in the room said were not going to work was something that the 20-year-olds and the 25-year-olds that said, this is something worth pushing, made it happen at the World Bank, at the IFC, at the national agencies, and they did so against the explicit directions of their seniors. Now, we have products in every poor country that are transforming the basics of energy access. And it used to be just lighting, but now we have devices that are solar refrigerators, that are solar-powered televisions. Here are mini-grids in a box you can see in the upper right, where you literally unpack a shipping container, comes with the panels, comes with the batteries, provides a community fridge, does Wi-Fi, et cetera. And the so-called development experts absolutely poo-pooed this. No matter what they say after the fact, it is simply the case that those in power said, not worth the effort because it's glorified flashlights. From there, the current topic of great derision are mini-grids. And I've just picked out projects that we ourselves are doing. This is a mini-grid in Oakland, California on the right, where 40 homes have agreed to wire together to share rooftop, to install collective energy storage. They're not using batteries, they're using flywheels. And then I've highlighted two kind of interesting luxury items in French Polynesia, the top pictures there, where communities where diesel power is well over $1 a kilowatt hour are converting to solar mini-grids. And then the bottom two are the kind of the more classic, a rural mini-grid in northern India we installed for South Sudanese refugees, and then a mini-grid in Kibera, Nairobi's largest slum, that is a women's community center. And so all of these are this classic mini-grid. There's a great debate that mini-grids aren't going to work, but the same community of young, now a little bit older, staff at the big development agencies are all exceedingly excited about this as a new way to bring clean energy at the block, peri-urban, and rural levels in ways that they're really fighting a battle against the more established development agencies. Now, I'm going to seem like what's going to do a bit of a switch gear, but I want to highlight the California story because while California is not normally thought of as a place of energy poverty, we have a significant low-income population, although California does have one of the highest expenditures of state money to provide energy for the poor. But the thing that's really motivated California's clean energy strategy is something that was mentioned several times earlier today, and that is the fact that California doesn't have a series of disconnected laws. California has a strategy. In fact, it's one that says we have an overall climate plan, but it relates to sectoral strategies for the area of energy, energy access for the poor, clean water for the poor, a carbon market, a whole set of features. And when we debate things in California, and as Senator can tell us, we often get things wrong, but even those who disagree ideologically understand why Senate Bill 375 that says communities may only do expansion of mini malls and things if they take into account vehicle miles traveled, and the vehicle miles traveled have to fit our climate law, that these pieces all fit together in a way that the debate, while often painful, is one that's really about the substance. And we've seen that time and time again when California voters, even during depressions, voted 60-40 to maintain California's climate law against a very well-organized and very well-funded effort to defeat it. And so if we go back to what really gave California the kind of the muscle to know it would work, this is a graph showing electricity consumption in California in blue and in the country, in the US overall in red. And through a series of measures at the residential, commercial, industrial level, California has kept electricity consumption constant per person since the 1970s. And that wasn't because of one technical innovation. That was a series of technical innovations built around a policy. This has led to all manner of innovations in the electricity sector that I won't have time to get into, but ideas about decoupling and about loading orders, ways to prioritize first efficiency and then clean energy. That strategy has worked and has worked consistently, and it really was based around this idea that there was a plan. And I urge I forget who it was who said, it might have been Jeff, that you have to have a plan. Places that have interesting individual successes need to translate those into overall strategies, and those that are pursuing interesting individual options have to find the ways to pull those together into a plan. So now we have efforts that are brewing in the process that will require every new home that's built to be highly efficient but generating all the energy it needs, so that we can really move towards not just a time of use, but a net metered market where price and where carbon are going to be the two metrics. California's clean energy targets going from 20% in 2010, we missed it, we made it a few years later. We're ahead of schedule for our 1/3 target for 2020, and we're on the way to 50% in 2030. And while it is briefly stalled, I believe that Senator De Leon's bill to bring us 100% renewable energy by 2045, and that includes a dramatically increased budget for electric vehicles, will pass in the coming 12-month cycle. And this is the kind of thing that you don't get if you don't put all these together. And in California, nuclear and large hydro do not count. So this is truly solar, wind, sustainable biomass, if there is such a thing, geothermal, and ocean energy. We've all seen the graph showing how solar power has gone on this amazing ride where the prices are dropping dramatically, and this is the so-called learning curve. Well, what we also know is that solar is now so cheap. Under 3 cents in Dubai, under 5 cents in Arizona, just incredible prices, has allowed us to think about solar not just as for lighting, but for all kinds of basic functions. So huge solar desert projects, but also lots of solar rooftops, although I do notice that you can have just as bad sprawl or just as bad a traffic jam in your electric cars. And so we need to think much more about that redesign of cities, but it shows we have the tools. The other feature, of course, is an electric vehicle is a wonderful tool, but if it's in a place with a very dirty power system, it's marginally better, not massively better, than a regular vehicle. But as you clean your electricity, as you can see if you look in California, where an EV is basically 100 miles a gallon, to some of the dirtiest places where it's only 30 or 40 miles a gallon. California's big issue, of course, is not making it happen at home. It's the fact that we are 1% of global emissions. And so an effort that has been spearheaded across the state is to partner internationally under the Under 2 MOU, for which almost 40% of the global economy has now signed on. My last point, which I'll try to do in 1 minute and 13 seconds, is to note that when we look at the grid at large scale, how can it play a role in this process? And the grid, this is the US grid, this is the European grid. The grid has, of course, been called the largest machine on the planet. It's also a machine that works in practice, but not in theory. No one, myself included, who does a great deal of grid analysis knows how to literally model the whole thing, which is another argument why practice and theory are going to have to work together here. But in our lab, what we've done is partner with the governments you see in green, Western North America, starting with California, Chile, Nicaragua, Mexico, China, Kenya, Bangladesh, to build a model of the grid system for each country and to utilize those to examine what's the role of emerging storage. And storage right now is evolving faster than solar ever did per dollar invested, meaning that we are now at a place where we can think about base load renewable energy if we can build out storage through technological innovation and through the level of policies like in California and Germany, each of which has a different flavor, but a version of a mandate for storage. I'll conclude just with highlighting that in our work in China with partners at several universities and at State Grid, kind of the ideal institution that has a massive budget to research but also to implement the power system, we are seeing that not only can we think about large amounts of renewables, so that China is probably going to meet its 2030 target of peaking carbon emissions perhaps a decade early. And China just announced something we're working on right now, a plan to now begin the phase out of internal combustion engine vehicles. Now, this is not going to happen overnight, happen long after 2030, but the idea that we could now be talking about getting electric vehicles as the primary means of transportation and phasing out EVs is kind of a remarkable thing that no energy theorist predicted even 15 years ago. So I see I'm 58 seconds over. I apologize, but I will stop there. Thank you very much.